This is a text-to-speech presentation. The original one was in Hungarian language. The text-to-speech software was from imtranslator.com.
Hi, welcome everybody. I'm Gábor Jeck from the ITS department of Raiffeisen Bank, and I am the third pillar of the Trinity you have seen in the previous presentations. So, there was development, quality assurance, and I am coming from the operations pillar. What would I like to talk about today? I would like to present what expectations we have towards release management from operations perspective. I will say a few words about the scripted deployment, about the different process parts, the security and audit provided by the tool, what challenges there were when implementing the tool, about the platforms covered by TRMT, scripting technologies. I will present a few statistics, and at the end, I am also expecting questions, of course. During the preparation, we sat together with my colleagues, and I asked them to write on a paper, completely freely, systems of criteria related to release management. And a well-socialized operator, even if woken up in the middle of the night, will recite these by heart. Obviously, the first one, the most important one, is the possibility to log and report. So, the sequence has an importance as well. Obviously, this is important because we have gone through so many audits. The previous colleagues related about 4 audits this year. I think I myself had more than 10 already. It is important to handle the permissions related to development, test, and live systems. Such a tool needs to be applicable for these. Obviously, separate permissions are needed in the development system, in test, and in production. It was a very important criteria from our side that this tool should not be purely for IT operations, but it should really contain the development and the quality assurance, and whoever else should have anything to do with it, they should all be able to use this tool. It should be fail-safe. It is obviously not a good thing if, say, during the Friday night deployment, when the system administrator launches the script, the deployment freezes with out-of-memory, or Java dump, or heap dump. Then, instead of paying attention to the actual deployment, and to the functioning of the deployed application, she needs to fight with the nuisance, and the problem of the deployment tool. Subverting it, getting around it. Obviously, it is not good if, for example, such a system is relatively easy to cheat. So, if the developer can directly deploy into production, or if the tool itself provides a possibility to hack the system somehow through a loophole, with simple scripts. The central management of source codes is a key question. When development starts, and the developers continuously bring new builds, respectively development results, it does matter what gets into the production system. The closed handling of these builds is important. They should really be handled securely. A very important part that is maybe connected with the first topic is, if we already have a log, and we create reports out of it, let's save what can be saved, so the tool has to be easy to back up and recover anytime. Parameterizing, let's separate the levels of the server and the application layer. The tool should provide the possibility for rollback. And it is a very important part that emerged in the meantime. It should not slow down, instead it should speed up the deployment process. About scripted deployment. The functioning of deployment scripts gets tested very precisely practically during the deployment. Obviously, in the production system, we will have to use the same tools, the same scripts, both in case of databases and deployment scripts. This is a key question. Obviously, the same builds have to be deployed in all environments, and these parameters have to be set on a common interface, uniformly, and these are set by the scripts. They need to be maintainable quasi on the managed servers, protected by permissions. The previous presentations explained that we would like to separate these responsibility levels somewhat between operators, developers, and even, say, quality assurance. Very clearly, the operator's side is responsible primarily for the servers, IP addresses, and for the operations infrastructure, and the developers are obviously those who prepare the different deployment script, and the other parts of the application, respectively the database scripts too. But it is not practical, if for example developers know the passwords, and the environment parameters of different systems, and I think it is not necessarily part of their job. This tool provides the possibility for everybody to operate in their own area. If the scripts are properly parameterized, from there on the system doesn't even give a possibility to make a mistake. How important is it to preserve the vitality of the environments? I think it is very important. In the current accelerated world, no organization can afford that the functioning of test environments, development environments, not to talk about the production, cannot be ensured on long term for some reason. You will also see in the statistics at the end, that many more of the different releases get into the development environment, but these need to be tested, used, and tried in some way. Obviously there can be problems in the developments in exactly these tools. These environmental systems enable the handling of these problems in a way that we make the release relatively quickly redeployable by using them. In case of a problem, we can use the TRMT tool to roll back to the previous version and deploy the version that is surely correct. How do we roll back? Using undeploy scripts. The process is very much regulated. If the result of the development got into CVS, from there on the process is almost automatic. All releases are generated through a check build server, and these releases already contain all existing information necessary for the deployment to be successful. It contains the binary. It contains the deployment scripts belonging to the release, and all the database scripts that are needed for the given deployment. I already mentioned a few words about permission handling. The developers can work in the development environments, however they cannot access the test and production environments. This is the area of operations. Only the operators having appropriate permissions can deploy here. And a very important part of it is, and it is a thing that is pretty frequently required by the audit, the collection of logs, to show what the operator really deployed. Obviously personalized permissions are needed. If there is say such a dedicated set of permissions called TRMT deployer, then we cannot tell who did what at which point in time. Therefore these permissions need to be created in a customized way, so that we know what our system administrator named Zoltan Kovats did yesterday at 12 o'clock, and this is beautifully visible in the logs. And obviously there is an important criteria: the permissions can be limited on the proper level or the proper way. Certain people may access certain servers and other parameters, and certain colleagues may not. It is very important how auditable and secure the product itself is. The information that consists of environment parameters, respectively the permissions and passwords of technical administrative users, these are stored in the tool obviously in an encrypted way and cannot be decrypted. The system records all activities in an audit log, everything including from login through running of different scripts up to modifying all kinds of parameters. And usually the favorite questions of audit that you have already seen previously, I will not read them. They can ask everything: when, why, how, with whom, how many times, and these audit information can be extracted from TRMT. What challenges did we have in relation with the implementation of the system? I wouldn't say that the system administrators didn't have sidelong looks at the tool in the first moment. Obviously there was a kind of resistance towards the tool up to the point when they understood that this is also for their benefit, and it can provide them help. Each system administrator has already prepared previously her own deployment toolset, small scripts using which she could juggle between the systems relatively quickly. But this is not the same as such a system surrounded by audit and having a much regulated process. A kind of continuous evangelization was needed why this is important, why this system is necessary. But I think we reached the point now that system administrators have already recognized its usefulness, and slowly they are becoming its vanguards. Now that the system is in use, it is difficult to hold them back, and they ask why we are not utilizing it in different other systems where we have the source code because they see its advantages. Indeed, from here on, using this tool, their responsibility is really minimal. They press a button and they say, "Yes, I am deploying now." I don't think anybody needs a better protection. A kind of internal regulation was needed, and I think this cannot be avoided in relation with the implementation of the tool. Obviously standards have to be developed. What are the tasks? Who does what? What is the procedure of deployment? Who has to bring what? What do external developers bring? What do internal developers prepare? When do we do an installation? When do we deploy to test environments, to development and to production? One needs to go through these relatively completely. And a kind of commitment is obviously necessary. TRMT supports these processes. Practically there is no chance that a development end result which is not called release gets into the application platform. The approval of scripts is enforced. If there is an error, it turns out quickly, and it can be retroactively retrieved from the log what kinds of errors occurred when deploying a given system, or whether there were any unsuccessful deployments that should have been noticed. What platforms are currently covered in our case? The largest part is in the largest SOA environment, the AIX environment, and somewhat on the AS400. These are all supported. We deploy using TRMT to the WebSphere application server, practically to all the platforms running J2EE applications. The WebSphere process server is also in the AIX environment. TRMT is under implementation for two products, BroadVision, respectively WebSphere Message Broker. Andras may confirm that we already had a successful deployment in the BroadVision test environment yesterday, and we hope we can also say the same about Message Broker soon. I wouldn't like to say much about this. Practically the builds can be performed through AND scripts, Unix shell scripts respectively. It is very important and it has to be highlighted that the SADMIN, that is the tool itself, natively supports the SADMIN administrative tool, additionally JACL and Jython in the different AND scripts. It can be used for quite a lot of platforms. We are using it or will be using it for BroadVision as well. And then almost at the very end some statistics from the system. 1033 successful deployments, and using mathematical operations it can be calculated how it is that 638 are in development, 336 in test, and 59 in production. Obviously the releases prepared for development are not final releases, those are tested, fixed, looked at, so this is a kind of continuous iteration. It can be seen from this that almost every second one out of these goes to the test environment, and a relatively narrow slice of it goes to production. Obviously development is an iterative process, this is absolutely correct and this figure is alright. And finally at the present moment we can say that we are already using the procedures of TRMT on 34 managed servers.